Assalamualaikum and hi student. In this slide, I will discuss about Cauchy Euler equation. First, I will talk about the introduction and later I will show an example of the differential equation that can be solved by using this method. Okay, in this session, we will consider a special type of second order linear equation where the coefficients are function of the independent variable. Okay, such equation is called Euler equation. So we first consider the Euler equation of second order given by ax squared multiplied by d squared y over dx squared plus bx ty dx plus cy equal to fx, where a, b, c are constant. So this one we call as a Euler equation. So this equation can be reduced to the ordinary differential equation with constant coefficient using the substitution of the x equal to et. So bear in mind this is x. Now we convert to the t terms, okay, instead of using x. So here x equal to et. So we will get t equal to ln x. Okay, so from here we can find dt over dx, which is equal to 1 over x. So when we want to find dy dx, let's say I want to find the dy dx. So since we know that y we consist of x, now we change into t terms, so we will have t terms in the y. So to get the dy dx, we need to solve by using chain rule. So we will have dy dt multiplied by dt dx. So dy dt remains. So dt dx is equal to 1 over x. Okay, so we bring x to the left side, we will get x dy dx equal to dy dt. We get another equation that represents our Euler equation, part of the Euler equation. So next we want to find this one. 2 here represent this one. Okay, if you can see here, x dy dx. Now we want to find the x squared d squared y over dx squared. Okay, so let's say we want to integrate. Okay, differentiate one more time. Okay, differentiate both sides. Okay, we differentiate both sides in terms of x. Okay, so I just summarize this. We will get x squared d squared y over dx squared equal to d squared y over dt squared minus dy dt. So this will be our third term. Sorry, this is 1, 2, 3, and we have another one which is first. Okay, assumption. So we have 3 equations here. Okay, next we want to substitute into Euler equation. Okay, so you want to substitute that into the Euler equation. So a, okay, we substitute here. Okay, I just substitute here. Write another pen to make it clear. So a remain. We have x squared d squared y over dx squared. So this can be represented by equation number 3. So we just substitute x squared d squared y over dx squared with the d squared y over dt squared minus dy dt plus b. So here we have x dy dx. So x dy dx is equation number 2. So we just substitute x dy dx with the dy dt. Okay, we want to change all the equation in terms of t now. Plus c. C remain and y also remain. So x, we want to change every x in terms of t here. So x here we based on the equation number 1. So we will have et. Okay, so remember, so this one we get from the equation 3. Okay, we get from the equation 3. So this one we get from the equation 2. This one we get from the equation 1. Okay, so when we simplify this form, okay, I just write down in the simplest way. So we write down ay double prime minus ay prime plus by prime plus cy equal to f et. Okay, so we combine the coefficient, we will get ay double prime plus b minus a y prime plus cy equal to f e t. Okay, by using, so this is the standard form of the equation. Okay, standard form of the differential equation where we have a constant, b minus a constant, c constant. Now we can eliminate x here, okay, into the standard form. Okay, by using the substitution of the x equal to exponent transpose, exponent t, sorry. Okay, let's look at example here. Find the solution of the differential equation. We have x squared y double prime minus 5xy prime plus 8y equal to 0. So remember, this is the Euler form. Okay, so we can check that x squared y double prime. Okay, so we have here x y prime, okay, y, and we have another function on the right side. So we can simply take out the a is equal to 1. Okay, so from the given equation a equal to 1, so b equal to -5, c equal to 8. Okay, and fx on the right side equal to 0. Okay, so by using the substitution of x equal to 80, okay, we can convert this one to the ordinary form. Then we can try to solve by using ordinary form. Then when we get the right answer, then we substitute back to the x term. Okay, so we have a, b, c, and fx. So we just substitute into the ordinary form. So I just copy that one back. A y double prime plus b minus a y prime plus cy equal to f e t. Okay, so a equal to 1, y double prime, b minus a, so b -5 minus 1, we have negative minus 6 y prime plus c equal to 8 y equal to fet. So it means here any value of x we need to substitute with the exponent t. So since on the right side we have fx equal to 0, so no need to change any value of x, so we just remain as 0. Okay, so when we use this substitution, we can see that this is a non-homogeneous equation where we have a, b, c constant. Okay, it is not in the form of Euler anymore because we have reduced it. So how to solve this one? We can solve by using characteristic equation. So that's right, m squared minus 6m plus 8 equal to 0. I'm sure you will understand this one. M minus 2, m minus 4, right, equal to 0. Then we have m equal to 2 and 4. So our y will become, so remember, we solve this, our form here is in term of t, okay, because we make use in t term. So our solution also will be in t. So our solution will become a e 2t plus b e 4t. Okay, because we solve this equation in terms of t, right? So now we already get the solution. Okay, but the question is in x term, so we need to convert back the t into x term. So since we know that x equal to et, okay, we convert using x equal to et, so we will get t equal to ln x. We just substitute back. So y equal to a e 2, t equal to ln x plus b e 4, t equal to ln x. Okay, so simplify this one. A e ln x power 2 plus b e ln x power 4. Okay, so we have exponent ln, then we simplify, we get a x power 2 plus b x power 4. Okay, so this is become our solution. Another way to find the solution, okay, so we can also use technique where y equal to a, we know that since we know that x equal to exponent t, okay, so we can rearrange a e t multiplied by 2 plus b e t multiplied by 4. Okay, so we can simply write down a e t equal to x power 2 plus b e t equal to x power 4. We get the same answer. Okay. Okay, I hope you understand. So all the best.